Welcome to the deep dive, where we take your curiosity and the stack of sources you provide and really try to extract the essential, actionable insights. Today, we are strapping into a vehicle that, well, it fundamentally broke the rules of armored warfare. We're diving deep into the story of the M18 Hellcat.
The fastest tank destroyer the world had ever seen.
Exactly. The premise alone is a paradox, isn't it? It hooks you right away, because in the final brutal years of World War II, when the undisputed doctrine was bigger means better, thicker means survival.
Right. Mass equals power.
Yeah.
American engineers built something that stood in direct, radical opposition to that whole idea. This was a machine that was definitely not the heaviest. It certainly didn't have the thickest armor. Yet somehow, it utterly defied the massive tanks fielded by the enemy. So our mission today is to understand, using the incredible material you shared with us, how radical engineering, focused entirely on tactical speed, allowed this machine not just to survive, but to, well, absolutely dominate against those iron monsters of the German army. We're really asking that crucial question. How could victory come not from being heavier, but from being smarter, more agile, and just exponentially faster?
Yeah, and it's vital to set the stage by looking at the conventional wisdom of the time. I mean, the Hellcat directly challenged the dominant philosophy of armored warfare, particularly one embraced by the German army. Their belief system was, well, pretty absolute and rooted in a decade of success. Speed and armor simply couldn't coexist. If you wanted power, if you wanted survivability in a direct fight, it absolutely demanded mass. It demanded steel.
You think about the Panzers. Exactly.
Yeah.
When you think about the German designs, the Tiger, the Panther, these weren't just machines. They were philosophies made of metal, real monsters. They were designed to absorb immense punishment, relying on sheer mass and the thickness of their hide to dominate any engagement. Their doctrine assumed, if you met an enemy tank in the field, the one with the thicker hide and the heavier gun would inevitably win. Simple as that.
Brute force geometry, basically.
That's a good way to put it, yeah.
And the M18 Hellcat was the ultimate American response to that geometry. It was such a radical answer. A machine built for survival, yes, but its armor wasn't measured in millimeters of hardened steel.
Yeah.
Its protection, its fundamental design principle, was velocity. They substituted mass for agility. And that switch, that strategic subtraction of weight and armor, it fundamentally altered the military calculus of the war, didn't it?
It absolutely did. It forces us, just as it forced the enemy crews back then, to completely redefine what protection truly means. Is protection solely measured in millimeters of steel? Or is it measured in the inability of the enemy to effectively locate you, track you, and target you in the first place?
Right. If they can't hit you.
Exactly. The Hellcat's design was explicitly engineered around that latter. Really disruptive definition.
Okay, let's unpack this engineering rebellion, because it really speaks to a different kind of strategic thinking happening back in the States. This wasn't about building a slightly better tank.
No, not at all.
It was about building a revolutionary counter-tank weapon that used asymmetrical advantage. The unique goal, and it was often controversial, right? The goal of the Hellcat wasn't to stand and fight like a traditional heavy tank.
No slugging matches.
It was built to hunt, to strike with overwhelming force and then vanish. It was designed from the ground up to be the ultimate hit-and-run specialist. And the source of this design rebellion, fascinatingly, wasn't traditional heavy industry. It started in 1943 at General Motors' Buick division.
Buick.
Yeah. You could almost say they were building a high-performance race car for war, not some rolling fortress.
And that automotive heritage is precisely why the result was so unconventional. They weren't constrained by traditional armored concepts, were they?
Not in the same way.
They were applying principles of high-performance engineering, prioritizing that power-to-weight ratio above everything else. When military contractors look at armor, they usually ask, okay, how thick can we possibly make it?
Right. Maximum protection.
But when Buick looked at the challenge, they asked, how fast can we make it while still mounting a lethal gun? That's a totally different question.
And the specifications really tell that story. They are, frankly, shocking when you put them next to the heavy armor doctrine.
Oh, absolutely. The weight alone tells the whole story of that strategic subtraction. The M18 weighed only 18 tons.
18 tons.
Just 18. And that figure needs context, because the German Panther tank, its contemporary and primary target, weighed twice that, around 45 tons.
Double the weight.
And the formidable Tiger Ada, closer to 56 tons. The Hellcat was carrying just a fraction of the mass of its main enemy.
That 18-ton figure is just Bonkers. And that weight reduction came at a price, didn't it? A trade-off that required enormous operational confidence.
A huge leap of faith, really.
The armor was infamously thin, a necessary sacrifice. Sources note its thickest frontal plate was barely over half an inch.
Half an inch.
Adequate to stop heavy machine gun fire maybe, but little else. A direct hit from anything heavier, certainly from the 88mm or 75mm cannons of the Panthers.
Catastrophe.
Yeah.
Instant catastrophe, yeah.
Mm.
They were sacrificing funnel protection entirely in favor of maneuverability and speed. But the core secret wasn't just the lightness. It was the power plant that enabled it. Under the hood was the source of its legendary velocity. The Wright Continental R975 engine.
The R975.
And what's important here is that this was a 400 horsepower radial engine, essentially an aircraft engine, shoehorned into an armored vehicle chassis.
Okay, here's where the engineering deep dive really pays off. It wasn't just the engine, though, powerful as it was.
Yeah.
To handle that raw power on rough terrain, they had to design a bespoke chassis. Our sources really highlight the importance of the torsion bar suspension.
Yes. Crucial element.
Standard leaf springs or older suspension systems, they would have just torn apart or buckled at high speed. But the torsion bar system allowed the Hellcat to hug the terrain and maintain that high velocity even off-road.
Gave it that smooth, fast ride.
So this combination, exceptionally powerful engine, specialized suspension, bolted onto a structure that was deliberately kept minimal, it resulted in a speed previously unimaginable in armored warfare. We're seeing reports this machine could be pushed to 55 miles per hour, an armored vehicle hitting highway speeds. How did the engineers even manage that power-to-weight ratio to create a record that arguably still stands for a mass-produced tracked vehicle?
They managed it because speed wasn't a secondary benefit. It was the design defense. By shedding all that mass, they achieved a power-to-weight ratio that allowed for blistering acceleration and top speed. A modern Abrams tank, for comparison, might hit 45 miles per hour on a road, but often less off-road. The Hellcat was doing 55 miles per hour through the European countryside in 1944.
Incredible.
It forced the enemy to react to the Hellcat's clock, not their own.
That fact alone is one of those signature deep dive revelations, isn't it?
Right.
It speaks volumes about the priorities of the design team. They created a mobile gun platform capable of changing position faster than any artillery piece or counterattacking armored unit could possibly react. But wait a minute, I have to challenge this point based on the realities of combat. Sources mention the M18's design had a critical, almost paralyzing vulnerability, the open top.
The open top, yes.
How did the crew psychologically justify operating a vehicle that was incredibly vulnerable to things like simple mortar shrapnel, snipers, or the dreaded tree burst, an artillery shell exploding in the canopy above, raining shrapnel straight down?
That is the essential trade-off. And you raise a crucial point about crew risk. The open top was definitely a vulnerability, but it was also seen as an operational necessity. It was open partly to shed weight, yes, but also to provide the crew with phenomenal situational awareness. They could spot threats and terrain hazards instantly.
Better visibility.
Much better. And crucially, the open top allowed for significantly faster reloading of the main gun. In a high-speed ambush, the ability to strike, reload quickly, and strike again before relocating was paramount. The open top facilitated that speed.
So speed of reload was key too.
Absolutely. But the crew justified the trade-off through aggression. They were told explicitly, your speed is your armor. If you get caught standing still, you're likely dead.
Simple as that.
But if you're moving, scouting, and relocating instantly after firing, the chances of the enemy getting a bead on you before you vanish are dramatically reduced. It required a fundamentally different and, extremely high-stress crew mentality.
And that dynamic is what drove those anecdotal accounts from the soldiers who operated it. Our source describes the experience. Driving the M18 felt exactly like driving a race car into war.
Great analogy.
That analogy perfectly connects the high-risk, high-reward nature of motorsports to the battlefield. You're relying entirely on precision, acceleration, and instantaneous reaction time, not on passive defense, which is what the German crews relied on.
It's a physical representation of that technological shift. The M18 prioritized agility and power output over raw bulk. Its effectiveness was predicated on the principle that the ability to outmaneuver the enemy was strategically superior to the ability to withstand their heaviest hit.
And that is a fundamental game-changing shift in military calculus.
So when the Hellcat actually entered combat, starting with the Italian campaign, it was an immediate test. Could this radical speed over steel doctrine survive reality?
The proving ground.
Exactly. And as you might expect, conventional wisdom held supreme initially. It led to outright dismissal from the enemy. The German high command looked at this lightly armored, open-topped vehicle and just completely underestimated it. Their commitment to mass blinded them.
Could have fit their model.
Not at all. They laughed at its light armor, famously calling it a tin can.
The tin can.
Yeah. This initial underestimation, fueled by their own doctrine of rigidity, became a critical factor in the Hellcat's early success. They simply weren't prepared for the speed it brought to the fight.
They saw a glass cannon and failed to realize the glass cannon was operating at a blinding 55-mile-per-hour away. That laughter must have turned to shocked confusion pretty quickly once the Hellcats engaged.
Oh, you bet. Imagine being a Panther crew, used to slow, decisive armored battles where positions were more or less fixed. Suddenly you're dealing with a vehicle that hits you, often from an unexpected flank, and then it just isn't there anymore.
Vanished.
Gone.
So the core of the Hellcat operational strategy was pure speed and surprise. The sources make this crystal clear. They weren't trying to hold a defensive line or get into a stand-up fight.
No way. They were hunters. The entire operation revolved around the strike, destroy, and relocate cycle.
Strike, destroy, relocate.
This cycle is what made the Hellcat revolutionary. The M18 would use its speed to approach the target, often over terrain that heavier Panzers couldn't easily navigate, maybe using an unexpected ridge or flank. It would strike, destroying its target with a 76mm main gun, and then immediately disappear. It would relocate, sometimes hundreds of yards away, before the enemy could mount any kind of counterattack, or, crucially, even know where the shot originated.
Okay, we have to clarify one critical detail about that gun, though. The 76mm main gun. While potent, it was generally considered, well, inadequate to reliably penetrate the thick frontal armor of the late-model German Panther and Tiger tanks, right?
That's absolutely correct. A key limitation.
This isn't the mighty German 88mm, so the speed wasn't just useful. It was an absolute necessity to get around to the thin side or rear armor. They had to flank.
Absolutely. The limits of the M18's armament reinforced the speed doctrine. If they engaged frontally, they were likely outmatched, gun versus armor. Therefore, their entire strategy was built around exploiting the operational weakness of the heavy German tanks, their sluggish turret traverse, and slow maneuverability. Speed wasn't a luxury. It was the mechanism that enabled the 76mm gun to be effective by turning a frontal plate vulnerability into a side armor advantage.
It transforms the traditional armored slugging match into a high-speed ambush campaign. In conventional warfare, once you fire, you expose your position, you commit to a static fight.
Right. You're stuck there for a bit.
The Hellcat refused that commitment. It made itself a ghost on the battlefield. This redefined survivability. You survive not by absorbing damage, but by avoiding engagement entirely on the enemy's terms.
And let's not overlook the psychological warfare aspect here. German commanders were accustomed to fighting vehicles they could observe, track, predict. The Hellcat created instant chaos.
How do you plan against that?
Exactly. How do you commit resources to defending against an enemy you literally cannot pin down? It forced a massive tactical overhead on the defenders, slowing their entire advance because they constantly feared that phantom flanking attack they couldn't respond to in time.
This also meant, didn't it, that the crews of the Hellcat enjoyed a massive logistical advantage that the German heavy tanks absolutely did not.
Oh, a huge advantage. The Panther and the Tiger were notoriously fuel-hungry. They broke down frequently
Maintenance nightmares.
and required immense effort just to transport or even cross smaller European bridges. They were just so heavy.
But the M18 at 18 tons?
Yeah. It could cross almost any temporary bridge the engineers put up. Its engine, despite its power, was relatively easy to maintain compared to the complex German drivetrains. And the sheer number that could be transported and fueled meant they were a far more deployable force. Their strategic lightness meant they were always in the fight, whereas the heavy German tanks were often bogged down miles away, waiting on fuel or repairs.
That's a massive operational win that stems directly from that design philosophy. It's not just about the bang-bang on the battlefield.
It truly highlights that optimal design considers the entire logistical chain, not just the thickness of the steel plate. The M18 crews were active disruptors, moving constantly to exploit opportunities, knowing their speed pretty much guaranteed them the first and often the last word in any engagement. This was a highly aggressive, offensive doctrine. It demonstrated a profound confidence in the American war machine's ability to capitalize on velocity. So while the successes in Italy definitely validated the doctrine, the Hellcat faced its true crucible, its ultimate test, in the final months of 1944.
The Battle of the Bulge.
Exactly. The massive, desperate German offensive. This was perhaps the most challenging and critical environment for any American armored unit to prove the worth of speed. The context here is just vital. Late 1944, the freezing forests, deep snow in Belgium and Luxembourg. American forces were caught utterly off guard by the German advance.
A complete surprise.
Totally.
Yeah.
The sources describe the panzers advancing through the snow like iron predators, just crashing through the defensive lines. This wasn't open field maneuver warfare like in France. This was dense, forested, highly confined combat. Visibility was low, and traditional flanking maneuvers seemed almost impossible.
And the German expectation was entirely based on their doctrine of mass, right? They assumed any light American forces would be quickly overrun or forced into hiding, a defensive retreat.
They expected them to turtle up.
The panzers relied on their weight to crash through those dense forests. But the Hellcat crews, they had a different plan. The contrast is stark. The panzers used their weight to crash through, but the Hellcats didn't hide. They raced right past the front lines,
Using that high-speed mobility.
to hit the German advance from the sides where they least expected it.
In the cold and the chaos of the Ardennes, speed became the decisive weapon. The M18's design absolutely shone in this environment because of that combination powerful engine, responsive suspension.
They could handle the terrain.
They used their velocity to outflank, outmaneuver, and ultimately outgun their heavier German opponents, who were actually struggling just to traverse the soft, snowy ground.
So the German heavies were bogged down by the conditions that the Hellcat could exploit.
Precisely. The slow speed of the German advance was the Hellcat's greatest ally. A massive tiger or panther lumbering along at maybe 10 or 15 miles per hour through the snow had a very limited field of engagement. The Hellcats could bypass bottlenecks, race through gaps in the forests, and suddenly appear on the side of a massive tiger tank that was simply too slow to traverse its turret quickly enough to counter.
Turning radius of a battleship versus a speedboat.
That's it. And we see evidence of extreme tactical use in the combat reports. Our sources highlight that Hellcats were often observed firing while moving at near full speed.
Firing on the move. At that speed.
Yeah. It's a testament to the engineering of the suspension and, frankly, the sheer bravery and skill of the crews. To maintain accuracy while moving at 50+ miles per hour through the uneven terrain of the Ardennes against a heavily armored enemy, that requires maximum proficiency and total commitment to the aggressive doctrine.
And the ability to fire on the move meant that the Germans weren't just dealing with a disappearing enemy,
No.
but an enemy that was actively engaging targets before coming to a complete stop. This must have compounded the difficulty of finding the source of the attack.
Massively. By the time the German crew identified the muzzle flash, the M18 was already halfway to its next firing position, or maybe already circling for a better angle to exploit a weakness.
Which brings us to that crucial statistical nugget, the one that underscores the Hellcat's absolute effectiveness, specifically in the defense of the Belgian crossroads town of Bastogne.
Oh, Bastogne.
This is the moment where the doctrine of speed truly proved its worth against the doctrine of mass, even in a defensive setting.
The Battle of Bastogne is legendary, absolutely. And the Hellcat played a pivotal role in maintaining that perimeter against the intense German siege. We have reports of specific engagements, most notably where a single platoon of Hellcats engaged the German advance near the town. Now get this astonishing result, derived from post-action reports. They destroyed 27 German tanks in just a few hours.
27 tanks, neutralized by a handful of those supposed tin cans. That is an almost unbelievable kill ratio for a unit composed of vehicles the enemy initially deemed militarily worthless.
It's staggering.
The impact on the German offensive capability in that sector must have been instantaneous, devastating. It stemmed the flow of iron that was intended to crash right through the American lines.
And the cost of that success just makes the case airtight. They lost only a handful of their own machines in that exchange.
Incredible efficiency.
This exemplifies the power of the M18's operational strategy. If you measure military effectiveness by the ratio of damage inflicted versus damage absorbed, the Hellcat created an entirely new, incredibly efficient standard. They succeeded by perfectly executing the core principle of their design. They won by never standing still.
Speed was their armor.
Literally, the speed served as a potent force multiplier. Because they were fast, they could choose the angle of attack. They could avoid the thick frontal plating, which, as we said, would have rendered their 76mm gun pretty much useless,
Right.
and instead engage the thin side or rear armor of the German giants. Their speed ensured they dictated the terms of every single engagement, turning a mismatch of armor, where they were theoretically vulnerable, into a tactical mismatch,
Right.
where they were overwhelmingly dominant.
It's the ultimate example of leveraging comparative advantage in military history, isn't it? They knew they couldn't win a traditional slugging stand-up fight, so they simply refused to fight one.
Chose their own game.
They chose the skirmish, the ambush, the high-speed pass. And the combat results: 27 tanks neutralized by one platoon near Bastogne. Well, they speak volumes about the power of that unconventional thinking. So once the dust settled and the strategic analysis began, and particularly when the Americans started interrogating captured German officers, there was this profound sense of shock, wasn't there? Disbelief that went far beyond typical wartime bravado.
Oh, yeah. Deep confusion.
This is where we see that final collision between the old way of war and the new reality the Hellcat had ushered in. The core astonishment of these German officers was revealed in their confused questions. How could something so light move so fast and kill our tanks so easily?
They just couldn't process it.
They had built the war machines of the future, or so they thought, the Tiger, the Panther, based on this single, rigid doctrine of steel, mass, overwhelming presence. And now they were being undone by what they saw as flimsy, open-topped, paper-thin American vehicles.
Designed by a car company.
Right. Their confusion stemmed from deep cognitive dissonance. Their internal military logic dictated that a heavy tank must always beat a light vehicle, period.
The rules they understood.
The fact that the M18 was open-topped, which they surely saw as a fatal vulnerability, became almost irrelevant because the Hellcat was gone before anyone could exploit it. This capability shattered their fundamental assumptions about combat kinetics. They believed in the sanctity, the immutability of the steel monster concept.
And this realization provides the clearest analysis of the tactical conclusion drawn from the Hellcat's performance. Technology and adaptive tactics had definitively outpaced brute strength.
Speed beats steel.
The high power-to-weight ratio, the advanced suspension. It meant that movement itself became a superior form of defense than static plating.
That is the ultimate takeaway for the history of armored warfare, isn't it? The Hellcat changed the game forever. It proved that maneuverability and quick decision-making, combined with sufficient firepower, were exponentially more valuable than static, thick defense.
You could argue this vehicle helped accelerate the eventual retirement of the whole super heavy tank concept, which became increasingly irrelevant after the war. Why build a mouse when a Hellcat could run circles around it?
Exactly. Before the M18, if you wanted to defeat a Tiger, you were expected to bring an even bigger gun or even more armor. The Hellcat showed you just needed to be smarter and faster.
A different approach entirely.
This created a new baseline for future military designs, prioritizing speed, power-to-weight ratios, overall agility concepts that still dominate military vehicle design today.
And this connects directly back to you, the listener, as an object lesson in innovation. The German assumption was the fundamental, long-held belief. Speed and armor couldn't coexist. Optimal design, as proven by the Hellcat, often requires questioning those foundational, long-held assumptions. By implementing strategic subtraction, removing the traditional element of heavy armor, the engineers created an entirely new dimension of advantage. Unprecedented velocity and maneuverability.
Less was more.
In a way, yes. They understood that a heavy, slow machine must be able to withstand hits from any angle. But a fast machine, it only needs to worry about the angle it chooses to present, which is usually no angle at all because it's already gone.
Proactive versus reactive.
That shift from reactive, passive defense to proactive, offensive engagement fundamentally alters the scope of strategy in any high-stakes environment.
And finally, let's consider the enduring symbol of the Hellcat from the perspective of the men who drove it. The legacy isn't just in the remarkable kill count, it's in the psychological connection those crews had with their high-risk ride.
A very unique bond.
Our sources beautifully sum up how the men felt about their vehicle. They admitted it wasn't the most protected, but they called it the most alive.
The most alive. I love that.
That phrase encapsulates the entire doctrine, doesn't it?
Yeah.
They weren't sitting behind thick steel walls waiting to survive a hit. They were actively using the machine's overwhelming capability to ensure their own survival through constant aggressive movement.
A machine that is the most alive is one that rewards proactive thought and demands courage. As the source notes, it was a vehicle that rewarded courage and punished hesitation.
No room for doubt.
If you drove it timidly, that thin armor would likely guarantee your death. But if you drove it aggressively, using its full 55-mile-per-hour capability to choose your engagements and vanish, it became, paradoxically, maybe the safest place on the battlefield for them.
Today, historians confirm its technical status. It remains known as the fastest tank destroyer ever built. But the story's more than just specifications, isn't it?
Much more.
It's the powerful promise it held during a desperate conflict. The promise that no matter the perceived strength of the enemy, the Tigers, the Panthers, the Panzers' speed, skill, and spirit, backed by truly disruptive engineering, could always turn the tide. Hashtag tag outro. Well, this has been quite a deep dive into the M18 Hellcat, the engineering rebellion that created a racer that truly outran death. We've seen how General Motors' Buick division executed this, well, rebellious piece of engineering that completely rewrote the rules of engagement.
Yeah, and proved that technology could disrupt even the most rigid military doctrines.
The central lesson, distilled from those combat reports and the profound German shock, it remains clear. Sometimes the lightest touchlight armor, high speed, aggressive maneuverability can win the heaviest war, even against the most powerful doctrine-driven opponents.
And if we take that knowledge and apply it maybe to our own fields, we have to consider the Hellcat's innovation strategy. The M18 proved that radical advantage often comes from strategic subtraction.
Taking something away.
Right. Removing the conventional, deeply ingrained requirement, in their case, heavy armor, to achieve exponential speed and agility. So think about the weight you might be carrying doctrinally, institutionally, or technically in your own work or study. What piece of armor are you relying on? What safe conventional element that, if you removed it, might unlock that 55-mile-per-hour speed and tactical advantage your competition would never anticipate?
What's your tin can solution?
Exactly. That's the lasting challenge, I think, and the profound legacy of the Hellcats